So again, like I said, the way that we'll always start off class is you'll come in with your homework and stamp sheet out. Start off by checking that. And then sometimes we'll have a warm-up. If so, just start working on that. If not, then you're just going to start into your homework. Okay, so this is just a little bit of practice before we go over homework and do our mini quiz on this. So we're translating. So the product of 3 and a number is less than 15. You see that word is. It says is less than. That means we have a symbol. Whenever you see is, we're going to have a symbol. If it's just is by itself, that's equal sign. Is less than or is greater than, that's the symbol alligator things. And then we have the product of 3 and a number. What do we put for a number? X, 1. Is less than 15. All right. So I like to go and put my symbol, is less than, and we know is less than 15. And then the product of 3 and a number. What does product mean we do? Multiply, good. So 3 times x, so 3x is less than 15. Yeah, you can do this. That would be fine. That would be fine, yeah. All right, questions with number 1? Awesome. So number 2, 9 less than twice the number is 5. So there's that symbol. Is 5. Is all by itself. That's just going to be that equal sign. We got our 5. Okay. Now our tricky thing here says less than. Yeah, that's our subtraction sign where we have to switch it. There's no is with it, so we have to flip the order. Less than, greater than. No is in front, you have to flip the order. So this is our subtraction sign, which means we flip it. 9 will come over here. And then twice a number. Twice means we're doing 2 times a number x. So we flip spots, and then we have is. I think the answer to that's actually set. Okay. Questions with number 2? Wonderful. So then for number 3, we're going to just write this one out in letters or in words. So this one you probably haven't seen as often, but this is x squared. So you can either write it as a number squared or a number times itself. I think it's just easier to say a number squared. If there was a little 3 on top, that would be cubed. You can say a number to the power of 2, but again, I think it's easiest just to say a number squared. Number squared. And then good, you don't have to get fancy with your words, you can just write down how you read it. Plus 4. And don't forget, is less than 2. I probably should have started with a capital letter. Jefferson. Okay. Questions with that? Okay. So let me go ahead and pull up the answer key for our homework. Just going to let me. Now remember, you can turn in homework for late credit. We'll accept it up to the day of the unit test. Okay, so there's our picture, but I'm going to go and show you. I think it's more important to see our answers this way because that's what we're looking for. Let's see if I can zoom in a little more. So go and take a look through that. Is there anyone else that I told them they need to go back and change something? Now, if you did not do your homework, do not just simply copy these down. You need to actually do it on your own. Copying would be a violation of the honor code. So a couple of things to kind of be aware of. Let's see if there are any super tricky ones I tried doing. Increase by, that's another way of saying plus. Decrease by, another way of saying minus. This one I thought was kind of weird, number 6. The speed of an airplane. We don't know what that is. We just use a variable to represent that. That's why we have x. Diminished by is another way of saying decreased by, which is another way of saying minus there. And notice here we have that less than, where we had to flip the order. And again, we have a few examples where instead of saying a number, they just said a phrase, and you had to represent it as a number. I think those are really weird ones. $14 was kind of weird too. Product, so we have multiplying. We have a number increased by 6 and the number decreased by 5. So it's the same letter that we're using. So we're increasing by 6 is plus 6 and decrease is minus 5.
The one has two x on it.
What's that? Which one?
I don't understand 15.
15.
The product of a number and 6 more than the number. Alright, so this is a weird one. We have the product of, so that means we're going to have multiplication. So what are the things we're multiplying? The product of a number, that's our x. And that indicates where multiplication is going to go. 6 more than the number. That by itself, the more than means we're going to have plus. And then we just want to flip the order because it's less than or more than we flip the order. And then we have to put that in parentheses because it's multiplying by all of that. A lot of times they'll say the quantity of, that helps you know parentheses as well. It's more common that we'll say the quantity of, just to help get that idea. Other ones that we have questions on. I was trying to ask your questions before the jitter. Alright. So if you take a look at your stamp sheet, what we're going to be learning about today is exponents, radicals, absolute value, and order of operations. So we'll take our mini quiz next, but then once we're done with that, exponents is like x squared or 5 to the third power. And then radicals, that's our square root, like 64, or cube root. And then absolute value tells us how far away it's 0. And then our order of operations, that's our PEMDAS or GEMDAS, depending on how your teacher taught it to you before. So these are the things we'll be going over today after our mini quiz. Again, I know the first chunk of Algebra 1 is just a review of what you did last year, so hopefully these are familiar, but I'll teach it to you like a course. Okay, any final questions on this? All right, go ahead and clear off your desks. We'll do our mini quiz, and we'll sit for next.
These grades.
These are actual grades. Please make sure your name is on your mini quiz. I don't know your handwriting yet, so it's not easy for me to figure out whose it is.
It is the 29th, right?
Today is the 29th. I haven't updated my board. There's not time travel. Thank you so much. When you're done with your mini quiz, you'll just turn it upside down into whichever version you have, and then if you would go and grab a calculator first. Go ahead and turn it in upside down and then grab the calculator. And so guys, at the top it says whether it's version A or version B, so that tells you which basket to put it in. We'll talk about how to do the different things on the calculator. Normally I have a calculator that I can pull up on my computer, but they changed our computers at the end of last year and they haven't put it on yet. Do you need to? Is there anyone else that needs one? So I'll show you at the front of the class on here, and I'll describe it to you, but unfortunately I won't be able to show you a picture of it. Hopefully by next class I'll be able to. Our tech people are pretty overwhelmed right now if we don't just talk. Okay, so let's go take a look at our notes. Everyone should have notes. Let's see, it's not working for some reason. Okay, so again, we're talking about multiple things today, absolute exponents, radicals, and order of operations. So our very first thing is a variable. And we've already kind of talked about this when we were translating, but a variable is a letter that is used to represent a number. So back in elementary school, we only used numbers, right? And then when we got to middle school, they started throwing in an X, and we're like, what in the world is X? It represents a value. We don't know what it is. Sometimes we can solve for it, sometimes we can't. So the one we use most often is X. Probably X and Y are the ones we use the most. Z comes next. And this may sound pretty crazy, but sometimes we actually use Greek letters. We won't use Greek letters here in Algebra 1, but in some of the other classes I teach, we use what's called a theta and whatnot. We'll stick with just X and Y and normal letters in here. All right, so you do want to know these vocabulary terms. I will be referring to these throughout the year. So when I say variable, I want you to know what I'm talking about. All right, coefficient. Coefficient, it is the number in front of the variable. So for example, if I say 5x, my 5 here, that's the coefficient. Well, so the problem is that it reads right here, but then it stops reading over here. This allows me to orient it. I think it's because I had it open and I disconnected my computer and I have to reconnect it. It's okay, we'll figure it out later. Sometimes the smartboard jumps around on me. I don't know. It's ready for a Friday.
An expression is, it's like an equation just without the equal, right?
Correct. So an expression is like an equation just without an equal sign. So it often will have variables and numbers. Sometimes it has addition, subtraction, multiplication, division. It's really just combination of letters and numbers and operations. So it's composed of numbers, variables, and operations. Does anyone know what I mean by operations?
What, like, what you're about to do?
Yeah, what you're going to do.
Addition, multiplication.
Very good, yeah. So we have addition, multiplication, subtraction, division. We could square root. It's really anything we're going to do to the numbers. What do we do to the numbers? So, for example, we'll continue with our 5x. We could have 5x plus 3 minus 10x plus 4 squared. Now, we will be simplifying these expressions. That's something that we'll be doing, I think, next class, or maybe a little bit today, where I can see I have 5x and negative 10x. I can combine those together. 3 and 4 squared. 4 squared is 4 times 4, so 16. We could add those numbers together. So we will simplify those expressions.
So we're combining the terms.
That's combining like terms, yeah. All right, so an equation must have an equal sign. So it's basically an expression with that equal sign. So if I were to take the thing we just had above, 5x plus 3 minus 10x plus 4 squared, and let's suppose we know this whole thing equals, I don't know, 102. That is an equation. It equals something that allows us to solve and find out what x is. Because right now there's only one, when we get later on in algebra, sometimes there's more than one solution for x. There right now is only one number for x that will make the statement true. Up here it's just an expression. We don't know what it has to equal, so we don't know what x has. All right, inequality. So this is where we have our greater than, less than, greater than or equal to, and less than or equal to. So it must have an inequality symbol. Inequality symbol. Alright, so these are the following. We have, let's see what should start with. We'll go with less than. Less than or equal to. Greater than. And greater than or equal to. So these are what I call like the alligators. Or do you guys know what Pac-Man is? I know it's from a long time ago, but you guys know what older stuff is, right? So sometimes you can think of it as like Pac-Man, where he's like, so alligator mouth, Pac-Man mouth, however you want to think of it. So an example would be 5x is less than 10. So with an inequality, there's actually a range of solutions. So for an equation, we only have 1 or 2 answers. For right now, in algebra, we're just going to have 1. Later on this year, we'll have 2 answers. But inequality is a range of possible solutions. So for example, right now it says 5x is less than 10. If I were to solve this, my answer would be x is less than 2. So what that means is I can pick any number below 2, and that will make this equation true. So for example, if I chose 1, 1 is less than 2. 5 times 1 is 5, and 5 is less than 10. So we actually have a range, a lot of solutions for it. All right, evaluate. So evaluate is when we are given an expression, but then they tell us what x equals, or what the letters, the variables equal. So what we do is we take those numbers and we plug those in. So we plug in a specific value. They tell us the value for each variable. Then we simplify. Now, if we have more than one variable, we'll be probably plugging in more than one letter or number. So evaluate, they give us what the variable number is going to be. We put that in. If we're solving, we don't know what the number is going to be. That's what we're trying to find out. All right, so when we are solving, we want to find a specific solution. And what I mean by solution, that's a number-specific solution, answer, or number. Those are all words you can think of. Right, so I'm trying to find out what does x actually represent. Is x5? Is it 2.8? All right, so this means we want to get it all alone. And when we say it, I'm going to change this. We want to get the variable all alone. I want you to know what it means, the variable alone. So when we solve, we have to get rid of all this excess stuff and get the variable alone. So for example, up here where we have the 5x is less than 10, in order to find out what x is, I have to get x by itself. And so we do that by dividing by 5. That's something we'll be learning when we're going back over later this week. Questions on our vocabulary? All right, so flip the page. Let's talk about absolute value. So absolute value is these bars here, and we have some number inside. You can see some examples here. Absolute value of 3, absolute value of negative 10, absolute value of 0. What the absolute value means is how far away it is from 0. So it is the distance from 0. So you can think of it on a number line. This is 0, 1, 2, 3. So we have both positive and negative numbers. Absolute value means the distance from 0. So let's say I ask for the absolute value of 4. 4 is 1, 2, 3, 4 away from 0. So the absolute value of 4 is 4. But let's say we did the absolute value of negative 2. Good, it is 2 away from 0. 2 away from 0, not 0 away from 0. So it's talking just about the distance. We can't have negative distances, right? I can't walk negative 5 miles. So it is always going to be positive. So it actually makes our absolute values very easy, because all we do is take the number and write it out as a positive.
So when the symbols from outside the box, that means there's no absolute value.
Right. So what we have to be careful with is absolute value only takes what's inside and makes it positive. Now we're in algebra 1, which means there's a lot of things we'll be doing to it, right? Our expressions are not just one single thing. So sometimes you'll be subtracting this away. So we simplify the inside first, and once we do that, we can get rid of our absolute value bars, and then we deal with what's outside and front. So let's go take a look at these examples. Absolute value of 3 is 3. Once you've done your absolute value, you take those bars away and you just write the number. absolute value of negative 10 is just positive 10. And again, we can remove those absolute value bars. What's the absolute value of 0?
0.
0. It's 0 away from 0, right? It's already home plate. Now, where it can get tricky are like 4, 5, and 6. Number 4, it says negative of the absolute value. We have to leave this alone and do the absolute value. So we still write the negative because it's outside of it. And then now we ask ourselves, what is the absolute value of 19? 19.
Wait, I don't understand.
So we have to, this negative is not inside the absolute value. So the absolute value can't get rid of it. The absolute value can only get rid of negatives inside. So we have to leave that negative sitting in front. So we leave the negative, and then we ask ourselves, okay, well, what's the absolute value of 19? The absolute value of 19 is 19. We've taken the absolute value, so we can remove those bars.
So basically, we just rewrite the thing.
Without the absolute value bars. So again, absolute value can only change negatives inside, not outside. So it gets really tricky with number 5. This negative is outside, so I have to still write that. They can't change that. And now that we've taken care of that, what is the absolute value of negative 2? Positive 2. Okay, so this negative had to stay there, and then we went ahead and simplified this, and that was just 2. So pretty much when you deal with your absolute values, anything outside stays the same, and then you just take the inside and make it outside. All right, and then number 6, there's nothing sitting in front, so we don't have to worry about that.
Well, half.
So it's just 1/2. Okay.
Can you change that into a decimal?
Yeah, that would be fine. You could put it as a decimal 0.5. I'm okay with that. That's the exact same thing. Good. So let's talk about where the absolute value bar is on your calculator. Okay. I talked to, do you want to go ahead and use this one as well? You're fine using that. But I want you to see this as well, just so you can kind of get familiar with it. Because in some later classes, you'll need to use these ones. So you are welcome to use the TI30X2XS. That's my favorite kind. That's scientific. But I want you to also see this as well. Okay. Does anyone happen to remember where the absolute value is? It's kind of hiding on your calculator. Does anyone remember where it is? It is under math. Okay, so I'm so sorry I don't have this to show you on the board. But if you look on your calculator, up here there's like the blue and the green button that's second alpha. Underneath it, it says math. So you want to hit math.
Second and then math?
Just math. You don't have to hit the second. Okay, so you hit math. And then you're going to arrow to the right. And you'll see, so you're going to go to the right.
Numbers.
Yeah. And it'll highlight NUN at the top. That stands for numbers. And option 1 says ABS. That stands for absolute value. It's not abs like your 6-pack, or lack thereof, but for absolute value. So when you hit enter, oh look, absolute value bars pop up. Okay. So you can actually type in any of these, and it'll tell you that. So let's say for number 6, we type in negative 1 divided by 2, hit enter, and it'll say a positive 0.5, which is left. Is there anyone that's not able to find the absolute value bar that needs help?
How do you fill it up again? You have to do the same thing.
Yeah, to bring it back up, you have to do the same thing. Math, arrow to the right, then abs. Now, when we did this one, we got an answer of 0.5. Does anyone remember how to change that back into a fraction? So we hit math, that same button, and the very first option says 1 frac, that stands for fraction. So if you just hit enter, it'll say answer arrow fraction, and then hit enter again, and it changes it back into a fraction. So if you have a decimal answer that can be written as a fraction, you can change it into that. That's really helpful when we get to the SOL, where you might get an answer as a decimal, but all their answers are fractions. To know which one matches up with, you can do the math. So the SOL this year, last year they allowed them to use both calculators and Desmos, And this year they're going to do the same thing again with calculators and decimals. When we get closer to decimal, we'll do more with decimals so you can kind of learn that. Questions with absolute value on the calculator? Let's go ahead and scroll down. Whoops. Ah, sorry. I changed pages rather than scrolling. All right, so now we have parts of an exponential power. All right, so exponents. Exponents to me are kind of the first big thing that you get to learn after you've learned variables. We're no longer just adding, subtracting, multiplying, dividing, but you have this thing called a power. It's a nice way to condense down a long range of a number multiplied by itself. All right, so let's just go ahead and do an example. We'll just say 5. Let me make sure it's not down here. 5 to the 3rd. So this big number here, this one, is what we call the base. Okay, so that big number is the base. The little number up above, that is our exponent.
We're multiplying the number by.
Exponent, sometimes you might hear me refer to it as a power. Now, we call the whole thing an exponential power, you can say the whole thing's power, but you'll hear us say like 5 to the power of 3, that's why I put power over there as well. So what this means, 5 to the 3rd, what this is saying is that we multiply 5 by itself 3 times. We go 5 times 5 times 5. So we're not saying 5 times 3, this number here tells us how many times we write 5. So it means we're going to do 5 times 5 times 5.
It's 125.
It is 125. Very good. So that is 125. Now, of course, on our calculators, we could type 5 times 5 times 5. But what if we had 5 to the 7th power, or 5 to the 72nd power? Would you really want to type in 5 times 5 72 times? No. So what you can do on your calculator is it has a power there. On our calculator, the way that the power looks is it's a little caret. So on our calculator, it's this little caret. Okay, so on your calculator, let's go and do 5 to the 3rd. You want to first type 5. Alright, so we're going to type 5. And then you want to look for this little caret. The caret is underneath your clear button. Okay, so hit that caret, and it, on these nice new calculators, it automatically puts in a little box up there. Sometimes the older calculators, like the calculator I had in high school, because I'm a little bit older than you guys, not by much, but a little bit, it would actually write the little caret there. But for these new ones, they put that little box up there. So now we can just go and type the 3. And then you can hit enter. Do you need the caret? So I hit 5, and my caret is just a button by itself. There. Put that, and then I can type in 3. And hit enter. Questions with that? Awesome. So we want to write this, we want to be able to fill out this grid. This is a typical type of grid you might see on a quiz or on a test. So we want to be able to know what it is in our power form, our exponential form, how we write it out in words, what it looks like expanded, and what the actual value is. So this is 8 squared, or 8 to the 2nd power. So we're just going to say 8 squared. Squared means a power of 2. If we were to expand this out, we just write 8 times 8, so we have it twice. And does anyone know what 8 squared is? 64. Very good. Right, so notice our next row only has the words. So 3 to the 4th. And what that means is 3 to the 4th power. Okay. So my exponential form, 3 is my base, and 4th means a power of 4. So 3 to the 4th. When we expand that out, 3 times 3 times 3 times 3. And I think that,
81.
is it 81? Yeah, just want to get a cube just because of that. Our answer is 81. So then our last one, in words, this isn't numbers, it's a variable. So we have to say a number cubed or a number to the third.
We can't say x to the third power.
No, we still want you to write out a number instead of x, yeah. So a number. And I like to say cubed. You can say to the third or to the third power. When we write this out, that's going to be x times x times x. Now, for our answer, we don't know what x represents, so we don't know the actual value. They would have to tell us what x there, so we're just going to put it right. Questions?
Wait, the answer would be that.
Well, we don't have a value for x unless they told us, so we can't really have an answer for it. You could just put x cubed again if you know. Okay, other questions with this? All right. Now our radical. Our radical is kind of a unique type of thing. This is actually what we call the inverse operation of our powers. So it's a way to undo a power. A power said we take a number and multiply it by itself. So like 8 squared was 64. Smart horse. Well, what the radical does, or a root, is it says, hey, I know the answer is 64. So what to the power of 2 equals 64? So before we didn't know this, now we don't know this number. So that's what we're trying to find out. Okay, so our parts of a radical. I'm just going to go ahead and put it, well, let's do an example. Let's say like, what's that? So this is a radical. The most common ones we do is square root and then cube root. So let's just say we have, we'll go with cube root. So we'll put a little 3 here. Let's say the cube root of 27. I know the answer to that. So let's talk about the parts here. This is called the index. Index. So an index of 3 we call a cube root. An index of 2 we call square root. We can have 4th root, 5th root, 8th root, 10th root, but in algebra we pretty much stick to square root and cube root. Yes?
Why do you have to write it on the top?
Why do we have to write it? We're just talking about the different parts.
It goes below.
I know, it's because, see, up here it's not aligned, but down here it is. I tell you, the smart board struggles sometimes. Okay, now this here, the number underneath, is called our radicand. Radicand. These words you just want to be familiar with so that when I say a radicand, you know that means it goes there. But on a test, I'm not going to ask you, what is the radicand? And then this symbol here we call a radical. Or you'll hear me say root. Alright, so it's the inverse operation of the exponent, so it's the opposite of it. And this index tells us what the exponent is. So if there is no index, if the index is not written, then we assume it's an index of 2, which is just our normal looking square root, like square root of 64. And like I said, the other common thing we have is a cube. So if we don't have a little number in there, it's automatically assumed a square root. So a radical is the inverse operation of an exponent. It's the opposite. What it tells us is, hey, I know it's a power of 2, so what number squared equals 64? We're trying to solve for this here.
Oh, so
Yeah, so that's where a variable would
So
be.
it doesn't show us the
So when it's a square we don't write into, you can write in the 2, it's not necessary though. But what this means is we're saying, all right, I have x squared equals 64. We're solving to find x. So we would square root, and we would get x equals, so the square of 64 is 8. So
We're finding square root.
we're finding square root, but what it means is we're trying to find that number there. So square root. Okay. And the inverse, or sorry, the index tells us what exponent it is. Okay. Now for this, we can definitely use our calculators quite a bit for it. Especially, like you might know the square root of 16, but when we have like decimals, that's kind of so easy to know. So again, you'll notice there's kind of 2 types that we have, the cube root and the square root. Now something to keep in mind is that a square root of a negative, we can't have a negative underneath the square root. But what's nice is if you forget that, when you type in your calculator will give you an error, which means, hey, it's a non-real answer. And when you get to algebra 2, it's actually what we call an imaginary number. It's an actual thing. It's not made up, it's a real thing. But you don't have to worry about that for right now. So we'll go ahead and put a note here. We cannot do square root of a negative.
So you just type it in normally and then
It would
add the negative sign.
So if you did a square root of a negative, your calculator would actually say error. You can't do that. So we would just put no solution or non-real answer. Did it give you an error? But that's only when the negative's underneath, just like our absolute values. You cannot do negative. But when we have a cube root, we have that cube root of a negative, we can do that. So we can do a cube root of a negative, but we can't do a square root. But again, your calculator will tell you when you can and when you can't.
Wait, so how would you find the square root for the first one?
So for the first one, notice our negative is outside. So just like our absolute value, we go ahead and write what's outside. We leave that alone. And then we do square root of 16. So we think to ourselves, what times itself gives us 16? 4. So the answer is negative 4. So again, what's outside stays there. And then we take the square root. Once we've done the square root, we get rid of that. You can actually type into your calculator negative square root of 16, that gives you negative 4. So let's talk about where the square root is on our calculator. This one's kind of hidden. So on the left side of your calculator,
It's next to 2.
yeah, so there's a button that looks like this. And above that button is a little square root symbol. So when we have to get something that's above that button, you'll see it's in blue. That means we have to hit the blue button, the second button. So we hit second. So you want to first hit the button second. And then hit your x squared button, and it'll have a little square root pop up. So that's how we get our square root there. Now, we need it to have negative square root of 16, right? So you can go ahead and type in your 16 and then go to the left. No, that's not going to work. Okay, we need to type our negative first. So let's type our negative. Notice there's a difference between negative and the subtraction sign, so make sure you type the negative at the bottom. And then we'll do our second x squared square root button. And then 16 and hit enter. Negative 4.
Wait, once you get this in the SOL, do you have to memorize everything? Or do they go?
They can't tell you anything on the SOL.
No, for the calculator.
Yeah, even for the calculator. So we'll use the calculator the whole year. So we'll keep practicing these things. So for this particular one, I go ahead and type my negative first. And then I do second. And my x squared button has a square root. So I do second square root, and a little root should pop up. You can type 16.
Oh, okay, got it.
Okay. So again, guys, anything outside of it stays there. It's what's underneath that we can change. All right, so the square root of 1/9. So in my calculator, again, I'm going to do second second square root, and then type 1 divided by 9, hit enter, and you should get a long decimal, right?
3 repeating.
3 repeating, very good. So let's change that to a fraction. Half frac, 1/3.
Wait, so did you just play for the math? Fraction.
Yep, and then hit enter. Did it work for you? Alright, I want you guys to try number 3. Notice our negative is inside the square root.
No solution.
Your square root again, second. Square. So now once you add it, then you do math. Just hit enter.
Every time I put go to the square.
Try to get the square root. So you want to hit second. And see the little square root right there? Like that. So what does it say for this one? Yeah, so it says ERR, that means error, non-real answer. So for this one it says ERR, error, non-real answer. So that's when we know there's no solution to this. So you can write no solution or non-real answer, either one is fine.
Also, you don't have to put an answer.
Nope, there is no answer for it. Not for Algebra 1. When you get to Algebra 2, there will be an answer for it. But for right now, we are only in the real number system, no imaginary numbers, no solution. Okay, now number 4 is a little different, right? We've got that cube root. So cube root of 169. Our cube root is a little hidden. We can't use the square root for that.
Math.
It's under math, yeah. So for our cube root, you want to hit math.
There's only 4. Oh, that's 2.
So you hit math. And then you'll see option 4 has a little cube root.
Can we change the decimal to a fraction?
Did you get a decimal for this one? Oh yeah, it is a cube root. I don't think this one changes to a fraction. You can try, and if it doesn't change to a fraction,
Alright,
it just
you want
stays
this
as a decimal.
decimal.
It's 2,700.
It's
We'll
like
leave
a
it as a
decimal, right?
decimal then. Yes.
5.5.
Oh, you don't get it. Where to find the cube root?
Yeah.
Okay, so everyone, let's review how to find the cube root. You want to hit math, and then option 4 has the cube root, so you just hit the number 4, and it should pop up with a little 3 square root, little cube root. Does that make sense? And then we can type in the 169 and hit enter, and you get this crazy decimal. We try to turn it into, 5.528774814. It goes on forever and ever. This one does not turn into a nice fraction, so we'll just leave it as a decimal. So this is 5 point, and let's go just to one place. 5.
What if the exponent is a different number?
So if it's like a little 4 there, a little 5. So under math, option 5, you'll see there's a little x.
Oh, you can change.
You do that one and it lets you change it. All right. So number 5 here, again, we keep the plus or minus sitting in front. Anything in front we leave alone. So now on our calculator, let's go ahead and type in square root. So that's just your normal second square root. Second square root. 0.25.
Wow. It's 0.5.
And it's 0.5. So we have plus or minus, that what's outside just stays there. 0.5.
Do you have to put
So
the 0?
you just found the
You can put the just
you
the
just found the square root of 0.25. Right?
Yep. All right, and now number 6. We're back to cube roots. We have to do math. Option 4, so we hit number 4, and we get that little cube root coming up. Now notice the negative is underneath, so we type negative 32.
It's another decimal.
It is another decimal, and it's not a nice one, so we'll write that one out as well. So we have negative 3 point, and that's going to round to 2. So it says 3.17. The 7 makes it round up to 0.2. questions
What
with
did
their
you,
radicals?
I forgot, what did you do to get the option to the exponent?
So we do math. Option 4 gives us the cube root. Option 5 gives you can change it to whatever you want. Okay. So then finally, let's go ahead and take a look at our order of operations. All right. So again, depending upon your teacher, they might have said PEMDAS instead of GEMDAS. So GEMDAS, PEMDAS, it's the same thing. PEMDAS stands for parentheses, but in algebra we have more than parentheses. We have other things that group, so we actually call it GEMDAS, where it's grouping. So our top thing says,
How do they have parentheses?
it does have parentheses, yeah. They're right above 8 and 9. Okay, so we have grouping, and examples of grouping would be parentheses, our square root, absolute value. What else?
We got peppers.
Oh, you guys have PEMDAS. Oh, well, fine then. We'll do. It's the same thing. So just go ahead and cross out your P and put a G there. So PEMDAS is just parentheses, but in algebra 1 we have more than just parentheses, right? We have square roots now. We have absolute values. I'm going to write that absolute value a little bit better. So these are things that group stuff together. So we call it grouping. Grouping. So for example, number 1, you can see 2 and 4 are grouped together in our parentheses. We have our square root of 9 divided by 16 grouped together. All right. E stands for exponent.
That's 1.
So that's when we have like a square, like that. So this tells us the order in which we have to do our operations. What do we do first? Well, first we simplify inside parentheses, square root, or absolute value. And then we do any exponents that we have. Another type of grouping is if we have a fraction bar, we have to simplify the top. The top is a grouping and the bottom is a grouping. So that would be another example. Okay, yes?
Do you want us to do the exercises?
We're going to do them after we go through all the operations. All right. Now, once we get to our MD, this is multiplication. Multiplication. And division. So first we do any parentheses or grouping. Next we do exponents. Then, when it comes to multiplication division, neither one takes priority. So you just go from left to right, whichever you see first. So if you see multiplication first when you go left to right, you do that. If you see division first, you do that. So multiplication, division, they're on the same level. You just go left to right from there. After you've done multiplication, division, then you finally do any addition and subtraction. And again, they are on the same level. So that's what we do last. We just go left to right. Whatever you see first, from left to right, that's what you do first. Okay. So let's go ahead and take a look at our examples. So again, we have, I'm just going to write it here for us. E, E, N, D, A, S. So first we do any grouping. So number 1, we see parentheses. We have to simplify what's inside the parentheses. What is 2 plus 4? 6. Good. Once you've simplified the parentheses, you don't need to keep writing parentheses, so this becomes 6. And then we have divided by 6.
That's 1.
Good. So then now there's no exponents. Next is multiplication division. So we see we have division, 6 divided by 6 is 1. And there's the answer.
Did you get a number with 2 and then you got 7 changes?
So the reason why they
with the 7.
you don't write this on, the reason why they put that is because they're rounding up on the calculator for you. You can just put the calculator. Yeah, that's a good job remembering. Alright, so number 2. So remember, we have to go in this order. We don't just go left to right. So we don't do 2 plus 8 first. No, addition is the last thing, right? So we first go this order, grouping. Well, I see a square root here, so I need to do the square root piece first. So this is my first piece. So I'm just going to rewrite everything else. 2 plus 8 divided by the square root. What is 9 times 16? Cool. Yeesh. Put that one into your calculator. What's 9 times 16?
144.
144.
That's 12. Screw with that.
Good. So we'll go ahead and do our next step. We haven't quite finished our radicals, so we'll go ahead and do that on your calculator. You do square root of 144, that is indeed 12. Okay? So we've taken care of our grouping. We've taken care of the square root. There are no exponents, so next is multiplication division. So let's just go left to right. The first thing I see is a division there. We don't do the addition yet, that's the last thing. The first thing is
I need to divide 8.
so I have 2 plus, so on your calculator, go ahead and do 8 divided by 12.
There, 2/3.
2/3? Good. So it'll give you decimal, and then you can go and hit the math frac. We get 2/3. Well, that's going to be our final answer. Yeah. And so then now you can just go on your calculator, you've already got the 2/3, just go and hit +2. Or you can do 2 plus 2/3, whichever you want. And we get 2 and 2/3, which is the same thing as 2.666666666 repeating. So you can just write it the line over top, or you can say 2.7 if you want to round. If you change it into a fraction would be 8/3. So any of these would be acceptable.
Is this thing? Is it the same as this one?
Yeah.
How do you do the addition of the fraction and the...
So you literally just in your calculator type 2 plus, and then you would do, you would want to go parentheses 2 divided by 3.
How do you like that fraction bar in this thing?
So on your calculators, oh that's right, you guys have the updated calculators. So on your calculators, you can actually get a fraction bar like that, which is really nice. So we would type 2 plus, and then to get this fraction bar, you hit our green button alpha and y equals. Extra little just pops up, just hit enter. It gives you that nice, beautiful vertical fraction bar. 2, and then you arrow down. Okay, let's take a look at a little more complicated one. Let's take a look at number 4. So number 4, we have for our grouping, we have these absolute value bars we have to do. Okay, so I'm going to do 12 plus. Inside 3 minus 9 gives me -6. We still have to do with the absolute value. So we have 12 plus, what is the absolute value of -6? 6. Okay, awesome. So we've taken care of the absolute values, right? You can still do this one on the calculator. You would just start off by typing the alpha y equals gives you the nice fraction.
Wait, so do you want to like eliminate everything first on the top and move to...
Yeah, so we have a kind of 2 groupings here. We have the grouping of the absolute value. And then we also do grouping in the sense that we have to simplify the top. And we have a bottom. So in the bottom, there's nothing to simplify. But in the top, there is stuff to simplify. So you want to simplify that first before you go there.
How do you get the cube?
So it'd be 9.
Good, so 12 plus 6 gives us 18. And then 18 divided by 2 is 9. There, should have gone a little more space. What's your question? Okay. All right, so then finally, let's go and take a look at number 5. So a similar idea as number 4 as it is for 6. We would want to do the top by itself, do the bottom by itself, and then in the end we would divide. All right, for number 5, we finally have an exponent. So the first thing is grouping. We see these brackets. That's just another way of doing parentheses. but we have parentheses inside of there, so we've got to start off with our parentheses inside. So what is 7 minus 4?
3.
3. So that little squared.
Do the exponent, which is 9.
Okay, good. So now we need to finish inside our parentheses. So we do our exponents next. So that would give us 3 squared is 9. And then we still have to finish inside our parentheses, the brackets there. 9 plus 3 is 12. And then now we can finally add it together. Give me a second. There we go. Okay, so again, we just have to keep going in that order. Look for any groupings first. That's our parentheses, square roots. If we have a division sign, you want to simplify a fraction. You want to simplify the top, simplify the bottom. Okay, your homework for tonight, the worksheet 6. If you would go to the calculator stack over there. So you'll notice on your homework sheet, it says your homework is worksheet 6. So we'll do worksheet 6 for homework, but you don't have school tomorrow or Monday, so I don't see you guys until Wednesday. Whoa! And again, just make sure you put the calculators back over there.
We go to TA.
Yeah, you're going to go to TA for a wonderful 90 minutes.
Wait, so normally when we have TA, is it stinger 2 and 3? Or
Normally, so later in the year, it'll be TA sticker 1. And then the next time would be sticker 2, sticker 3.
so we stay here for 90 minutes, yeah?
Not 90 minutes, it would be our 90 minutes and then a 45-minute block after that. I know, so much math. Those days are long days. So our class is normally 90